The first thing we're going to talk about is hash functions. Hash functions are a type of function that takes a long input and gives out an output that is always the same size. For example, we can have a function that takes a long string and returns only the last 4 characters. This is an example of a hash function. In fact, what we are looking for in cryptoeconomics is a cryptographically secure hash function. So a cryptographically secure hash function is a hash function that also has some important rule. The rule is this: for every 2 inputs you give to the function, no matter how similar they are, the hash of a cryptographically secure function has to be completely different. So if I gave the function the number 1002 or 1003, the output should be very, very different. There is one caveat though. If you drill down to the math, you find that it is not really possible to do it for every imaginable input. So what is the catch? We do it in a probabilistic way. How does this work? Each bit in the output of the function is either 1 or 0. Our final output has 256 bits to it. It is 256 bits long. What this means is that the option for our number at the end result of this hash function is one of the numbers from 0 to the highest number with 256 bits. What are the options? The first bit can be 1 or 0. So we have 2 options for this. The second bit can also be 1 or 0. So for that we get 2 times more options, which are 4 options. The third bit is again twice the options for that. So looking at the process, every time we add another bit, we have 2 times more options. Okay, what do we get from all this? How fast this goes doesn't always appear obvious to us. Let's test out our intuition. 2 times 2 is 4. Cool. 2 times 2 times 2 is 8. Okay. How big is 2 times 2 times 2 times 2? Okay, 16. We get it. What if we have 2 to the times of 8? Okay, look at the calculator. You get 256. Now, how big do you think is 2 to the 14 is? Guess, and then test it out. Did you get it close? In my calculator, it says 16,384. Okay, now think of how much is 2 to the 100. That means 2 times 2 times 2, 100 times. Guess, really. Okay, I got this number. This number has 31 digits. How do you even read it out loud? I have no idea. Okay, if you get a headache from that number, you're not alone. There are in fact less atoms in the Milky Way galaxy than options to pick a number from 1 to 2 to the power of 100. So in our space of probability, we have the choice of 2 to the power of 256 numbers. This is insane. Would you bet on these odds that a cryptographically secure function won't give you the same output twice? It's like someone would pick on blind 2 atoms in the galaxy and then that they would happen to be the same one. Only our case is much, much less likely. So to wrap things up, this is what we mean when we say it is very high probability but not 100% sure, because there is always the very, 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 very slight chance of getting the same number twice. Later down the line, we'll see why this is so important and why the whole cryptoeconomic paradigm is built on top of this idea, amongst other ideas too. Now, another feature of these hash functions is that if I tell you what the output was, it is very difficult to figure out what the input was. In the transaction and block structure, we will see why this is also important. Okay, to wrap things up now, we'll show you some examples using the website miraclesalad.com. This is what happens if we use the hash function for the hello world string. Look what happens if I change only one letter. The hash, we can see, is completely different. This hash function we use is called MD5. You can give it a try yourself. In fact, there are many more hash functions, but that's out of our scope. So I'll wrap it up today for the hash function lesson. I hope you guys enjoyed watching, and I'll see you in the next lesson we have.